In this video, we are going to derive equations of motion for a uniformly accelerated motion. It is a graphical method. We are using velocity time graph. Okay. First, let us write the consideration. What do we consider? You have to write this. Consider the motion of a body moving in a straight line. Let the initial velocity be u. The body accelerates uniformly with a uniform acceleration a. Let v be the velocity of the body after time t. Okay. We have to prove these three equations of motion. V equals to u plus at. This is the first equation of motion. The second one is s equals to ut plus half at square. And the third one is 2as equals to v square minus u square. In the examination, only one may come to prove. Okay. If only one question comes, you have to write the consideration. So the first one, let me try to prove the first one. V equals to u plus at. According to the consideration, the initial velocity is u. Let this be the initial velocity. It starts from u. So the velocity at time equals to 0 will be u. The height of this point will be u. It is at time t equals to 0. Okay. Initial means time equals to 0. It accelerates means the speed increases. It increases to time. It increases to v at time t equals to t. When the time taken is t, the velocity becomes v. Here, the velocity will be v at this point. So, the height of this point will be v. It is the final velocity. And this is the time exists. This is time t equals to 0. Here, time is t. Time is 0 here. Time is t here. Okay. At time equals to 0, the velocity is u. At time equals to t, the velocity becomes v. Let me draw a perpendicular line here. Let it be O, A, B, C, D. Okay. Number 1. We know that, right, we have acceleration. Let us write acceleration equals to slope of the vt graph. Slope of the graph. The graph is vt graph. It will be okay if you write the slope of the vt graph. Then what is the slope here? The slope is perpendicular height by base, p by b, p by b, perpendicular by base. Then what is p here? P is BD minus CD. The base is BC, it is BD minus CD. We'll get this. Okay. BD minus CD. We'll get BC. Okay. It is V minus U. BD is V minus U. BC is equal to V minus U. That is the perpendicular. Okay. Alright, implies A equals to P is the perpendicular is V minus U. Then the base AC is equal to time T. AC is T. Cross multiplying, we get AT equals to V minus U. Interchanging their positions, V minus U equals to AT. V minus U equals to AT. Then V equals to, transposing minus U on the right side, it will become plus. Okay, plus U. U plus AT. This equation is called the first equation of motion, or velocity-time relation. Okay, velocity, both are velocity and time. A is constant. The second equation of motion is S equals to ut plus half AT square. S is the displacement. Okay. Number 2. We know that from the VT graph, the displacement is equal to the area enclosed by the graph line and the x-axis. Area enclosed will be the area of this trapezium. So, displacement S equals to, this S is displacement. Displacement S is equals to area of what? Trapezium OABD. Of trapezium. Let me write trapezium. Trapezium OABD. Then what is the area of the trapezium here? It is half into sum of the parallel sides OA and BD. They are what? OA is U. OA is U and BD is V. Let me write in formula first. OA plus BD into the height or the altitude, that is AC or OD. Let me write OD into OD. 1/2 OA is U plus BD is V and OD is T. We have this half U plus V into T, but we know that V equals to U plus AT from the first equation of motion. Putting the value of V in this equation. Replace the value of V with this. V is here. You can replace it with its value U plus AT. Replace V with U plus AT. Therefore, S equals to half U plus what? V. V will be, this U is this. And this V will be U plus AT. U plus AT. Then, what else? Into T. Into T. Again. 1/2 U plus U is 2U plus AT into T. Let me multiply with T first. 1/2 T into 2U is 2UT plus AT into T is AT square. Then what do you get? What do you get? Let me continue here. Implies S equals to half. Let me break the bracket. Half into 2ut plus half into at square. Then we get S equals to ut plus half at square. This is the second equation of motion, and it is also called distance time relation, position time relation. Position time relation. Now we can move to the third equation of motion. Everything is same till this equation, till this line. Third equation of motion. Displacement is S equals to area of trapezium over BD again. Everything is same till here. But you have to put the value of T. We know that, right? We know that. If you don't know, you can write. We know that we know that A equals to V minus U by T, or from this equation you can write, interchanging the positions of A and T, we have T equals to V minus U by T. V minus U by A. Putting the value of T in this equation. What do we get? We get S equals to half. Let us rearrange this. V plus U. Let me write in this form. V plus U. T is V minus U by A. V minus U by A. I write in this order because it is in this order. V minus U by A. Then what do we get? Cross multiplying 2AS. 2AS equals to what? V plus U into V minus U. 2AS equals to A plus B into A minus B is A square minus B square. So we get this equation, the third equation of motion. 2AS equals to V square minus U square. It is also called position velocity relation. Position velocity relation.